Okay, we're back to the big screen here where we're going to solve this problem. So if you guys didn't try it yet, pause the video now and try to do this problem. The formulas are all here for upper and lower control limits of X bar and R charts. The table, the standard table is here. So you can pause it and try to do by yourself. The X bar chart is here, X double bar, and the R bar is here. So try to do it, pause the video. If after you finish, just take a look at the rest and see how I did the math, okay? So for upper control limits and lower control limits of X bar, so let's take a look at the problem. Sunny Soda Inc. is interested in tracking the quality of 12-ounce bottle filling line. It must fill with the tolerance 12 ounces per serving. The design standard is 12 plus or minus 0.1 ounce. We're not going to use that yet to look at control limits. This is specification limits, okay? So this is not control limits. So the control limits, if the process is under control, yes or no, these are the formulas that we need to use. So let's start with upper control limit for X bar equals X double bar, which we know is the 12.0095. I cannot make any mistakes because I'm writing with a pen. Let's see if that works. A2, so now I need to take a look at the table, and to take a look at the table I need to find N, right? So N is the number of observations in each sample. So I have 1, 2, 3, 4 observations in each sample. N equals 4. A2 equals 0.73. So 0.73 times R bar. Okay, so R bar is here. The 0.12666. Okay, and this is the formula for the upper control limits. So doing that math, we get 12.1018. That's the upper control limit, and then I can calculate lower control limit for X bar. It's going to be the same, 12.0095, but then minus 0.73 times 0.12666, which is A2 times X bar, and then I'll get 11.9171. So I have my upper control limit, X bar, lower control limit of X bar. Then I can calculate upper control limit for R, and the formula is there. D4 times R bar is the same N equals 4. D4 is 2.28. So 2.28 times R, which is here, R is 0.12666. So that's the upper control limit for R bar, and it's 0.28904. And the lower control limit for R is going to be the D3, which is 0 times 0.12666, which of course is going to be 0, right? So I have upper control limit for X bar, lower control limit for X bar, upper control limit for R, lower control limit for R. And to answer the question, are the process average and range in statistical control, I need to take a look at the data set, right? And then I have to take a look at the X bars and R charts. So the question is, are any one of those X bars outside those limits of 12.1018 or 11.9171? So we can take a look here. No, right? So all of X bars are within the limit, so the process is under control on X bar. And if you look at the range, have to be between 0 and 0.28. It's a little bit easier to look at. So do I see any values higher than 0.28? No, I don't see, right? So Yes, the process is under control. Yes, because all x bars and r are within control limits, right? Okay, and that's the answer for this part of the problem.